Good morning, student. Welcome to TYBSc Organic Chemistry. I am Dr. Kailas Labhade, Associate Professor, Department of Chemistry, S.V.K.T. College, Devlali Camp, Nashik. Today, we are going to start a new chapter, that is rearrangement reaction. Today, we are going to see what is rearrangement, different type of rearrangement, different intermediate that are involved in rearrangement reaction, and finally we are going to see Beckmann rearrangement. At the end of this session, students should understand what is rearrangement reaction, what are different type of rearrangements, classification of rearrangement reaction. They should able to understand various reaction intermediate involved in rearrangement and mechanism of Beckmann rearrangement. First of all, what is rearrangement reaction? Rearrangement reactions are the reactions in which carbon skeleton or the functional group of the molecule undergo changes. Another definition of rearrangement reaction: migration of an atom or group from one center, that is called migration center, to another center, that is called migration terminus within the molecule, is called rearrangement reaction. Let's see in this diagram. The X is migrating group, Y is migration origin, and Z is migration terminus. When X rearrange itself and get attached to Z, it is called rearrangement. These are some silent features of rearrangement reaction. In general, rearrangement takes place between 1-2 adjacent carbon atom, that is called as 1-2 shift. Long range rearrangement are also possible, that is 1-3 shift is also possible. There are different types of rearrangement, that is called nucleophilic or anisotropic rearrangement. In this rearrangement, migration groups move with the electron pair. Then electrophilic or cationitropic rearrangement. In this case, migrating group move without electron pair. For example, Fry's rearrangement. Another type of rearrangement is free radical rearrangement. In this rearrangement, migrating group moves with single electron. For example, Fry's rearrangement. Before starting this rearrangement reaction in detail, we are going to see the crossover experiment. Now, what is crossover experiment? When rearrangement takes place, sometime we confuse whether that rearrangement is intermolecular or intramolecular. For deciding intermolecular or intramolecular nature of the reaction, crossover experiment is used. For example, a mixture of two structurally related substrate, that is XAB and YCZ, are allowed to react to form a product, and after completion of the reaction, products are analyzed. If 4 products are obtained, then we can say that that reaction is intermolecular reaction. And if only 2 products are obtained, then we can say that that reaction is intramolecular reaction. This is explained on next slide. Let's see this. These are 2 substrates. XAB is first substrate, YCZ is another substrate. They allowed to react, and after reaction, 2 products are obtained, ABX and CZY. In first product, group X, which is attached to A, is migrated to atom B, and in second case, group Y, which is attached to C, is migrated and get attached to Z. In this case, only 2 products are obtained, and that's why it is called as intramolecular rearrangement. Now in next figure, we get 4 products. product first is ABX, product second is CZY. These two products are similar to first reaction. In addition to this, there are two more products are obtained, ABY and CZX. In case of ABY product, Y group from second substrate get attached to first substrate, and in case of CZX, X group from first substrate get attached to second substrate. That's why it is intermolecular rearrangement. In this case, two molecules involved in rearrangement, and there are also exchange of the substituent between these two molecules. Now, type of rearrangement reactions. These three are the important types of rearrangement reaction, that is 1,2 rearrangement reaction. When rearrangement takes place in between adjacent center, then it is called 1,2 rearrangement reaction. Then pericyclic reaction. In pericyclic reaction, there is simultaneously bond breaking and bond formation take place. And third one is olefin metathesis. In olefin metathesis, alkylidine group of two alkene interchange with each other, and there is formation of two new alkene. We are going to see all these three rearrangement in detail. First of all, 1,2 rearrangement reaction. A rearrangement in which a substituent move from adjacent carbon in an chemical compound is called 1,2 rearrangement. Now, in this case, there is carbocation. This carbocation is primary carbocation. We know that stability of carbocation is tertiary greater than secondary greater than primary. That's why when primary carbocation is formed, it tries to convert itself into secondary or tertiary carbocation. In this case, R group migrate from that carbon to that carbocation, and that's why new carbocation is generated, and in that case, that carbocation is tertiary carbocation. This migration is because of higher stability of tertiary carbocation as compared to primary carbocation. In second example, migration of R group, which is attached to carbonyl group, is shown, and in this case isocyanate intermediate is obtained. This type of rearrangement are called as 1,2 rearrangement reaction. Important example of 1,2 rearrangement reaction is Wagner-Merwin rearrangement. In this case, alcohol, that is isobutyl alcohol treated with acid, bad leaving OH group is converted to good leaving OH2 group. OH2 positive is good leaving group, and after removal of water, that is OH2 positive, carbocation is generated. In this case, this carbocation is primary carbocation. It is less stable. That's why hydrogen atom, that is hydride, is shifted from carbon atom to that positively charged carbon atom, and that's why we get tertiary carbocation, as tertiary carbocation is more stable. After that, addition of water produce alcohol, that is tertiary butyl alcohol. In this case, expected product is tertiary butyl alcohol, and it is obtained by rearrangement reaction. This is another example of Wagner-Merwin rearrangement. Isobornol is the starting compound. It contains OH group. In acidic medium, OH group get protonated. It become good leaving group. It leave the molecule. There is formation of carbocation. Carbocation is secondary carbocation. That's why it tried to convert itself into tertiary one. In this case, the methyl group present at bridgehead carbon atom, and generation of carbocation at that place is not favorable. That's why bond migration take place, and after bond migration, we get campene as a product. Now, second type of rearrangement reactions are called as pericyclic rearrangement. These pericyclic rearrangement involve multiple bond breaking and multiple bond formation process. Transition state has cyclic geometry and all the processes are taking place simultaneously. That's why the mechanism is concerted mechanism. Example, Kailas rearrangement. In this case, allyl vinyl ether is shown, and when this allyl vinyl ether heated, it undergo 3,3 sigmatropic rearrangement and produce gamma delta unsaturated carbonyl compound. This is pericyclic reaction. Now Diels-Alder reactions is another example of pericyclic reaction. In this case also there is movement of pi electron in that system taking place. In Diels-Alder reaction there is diene as well as dienophile. In this case 1,3-butadiene and ethylene are two substrate molecule, and after undergoing Diels-Alder reaction there is formation of cyclohexene as a product. In next example, it is 1,3,5-hexatriene. When this compound is heated, it undergo Diels-Alder reaction, bond shifting, that is bond breaking and bond formation taking place, and after that we get a compound that is 1,3-cyclohexadiene is the compound. In third example, 1,3-hydride shift is shown. Hydrogen atom of the CH3 group migrated to third position to produce a product, and in this diagram it is shown how that migration of hydride is taking place. Then third type of rearrangement, that is called olefin metathesis. In olefin metathesis, there is formal exchange of alkylidine fragments between two alkene. It proceeds through 4-member intermediate. Rearrangement of substituent takes place to form two new carbon-carbon double bond. Let's see. These are two vinyl compounds, and from two vinyl compound, two new alkenes are produced. Interchange of the group are taking place. R1, which is the part of second molecule, attached to first molecule, and hence rearrangement is taking place. And this rearrangement proceeds through cyclic intermediate, that is 4-member cyclic intermediate is obtained, and after that the products are formed. Let's see classification of rearrangement. First type of rearrangement is rearrangement to electron deficient carbon. Pinacol-pinacol rearrangement is the example of this type of rearrangement. In this rearrangement, carbocation is the intermediate and there is migration of alkyl group, aryl group, hydride. Sometimes there is migration of bond also taking place. This is called rearrangement to electron deficient carbon. Then rearrangement to electron deficient nitrogen. In this case, nitrine intermediate is formed. Example is Beckmann rearrangement, Hofmann rearrangement. These are the rearrangement which involve electron deficient nitrogen. Then rearrangement to electron deficient oxygen. Generally oxonium ion is intermediate in this rearrangement reaction. Example is Baeyer-Villiger oxidation reaction. Then sigmatropic rearrangement. In sigmatropic rearrangement, simultaneous bond formation and bond breaking taking place, and the example is Kailas rearrangement. We are going to see all these reactions in detail. First of all, rearrangement to electron deficient carbon. This type of rearrangement proceed through carbocation intermediate. These are some features of this type of rearrangement. Less stable carbocation can rearrange to more stable carbocation. When primary carbocation is formed, it is converted to secondary, or secondary is converted to tertiary, because tertiary carbocation is more stable as compared to secondary carbocation, and secondary carbocation is more stable as compared to primary. Stability of carbocation is also depend upon other factors like steric effect, inductive effect, resonance effect. These rearrangements involve generally hydride transfer, alkyl transfer or aryl transfer. In some cases, there is bond migration is also possible. Now, classical and non-classical carbocation. Classical carbocation is the carbocation which has 6 electrons involved in 3 chemical bonds, and non-classical carbocation is the carbocation with 3 center 2 electron bond, that is 3 atom sharing 2 electron. In this figure it is shown classical and non-classical carbocation. In first structure there is classical carbocation. In classical carbocation there are 3 bonds associated with that positively charged, 3 bonds sharing 6 electron, and in non-classical carbocation that positive charge is shared by 3 atom, means 3 atoms sharing 2 electrons. Now, rearrangement to electron deficient carbon. Example is pinacol-pinacol rearrangement. In pinacol-pinacol rearrangement, 1,2-diol is converted to carbonyl compound, that is aldehyde or ketone. 1,2-diol contains 2 hydroxyl group. Out of these 2 hydroxyl group, one group is protonated by acid, OH group is converted to good leaving group, OH2 positive is good leaving group, OH2 positive leave the molecule, and there is formation of carbocation. Now migration of methyl group from another carbon take place and there is formation of another carbocation. In this way rearrangement taking place and there is formation of aldehyde or ketone as a product. Now why this type of migration is taking place? We have already discussed the stability of carbocation. Based on stability of carbocation, the migration is possible. Example is Friedel-Crafts alkylation reaction, when benzene react with N-propyl chloride in presence of anhydrous aluminum trichloride, isopropyl benzene and N-propyl benzene, these 2 products are obtained. Out of that, isopropyl benzene is the major product. Out of these 2 products, N-propyl benzene, which is minor product, is normal product, and isopropyl benzene, which is major product, is rearranged product. In this case, it is shown how that rearrangement is taking place. That is, N-propyl chloride get associated with AlCl3 and there is formation of carbocation, which is primary. Hydride shift taking place and we get that secondary carbocation. Now the product obtained with secondary carbocation is major product and the product which is obtained from primary carbocation is minor product. Now rearrangement to electron deficient nitrogen. In this case, it is shown how electron deficient nitrogen involved in the rearrangement reaction. Structure first, when Z is equal to Br or Cl, it undergo Hofmann rearrangement. When Z is equal to N2, Curtius or Smith rearrangement. When Z is equal to OCOR, Lawson rearrangement. Silent feature of this type of rearrangement. These rearrangement involve degradation of carboxylic acid derivative to amines. Rearrangement of acyl nitrine to isocyanate is there. In earlier slide, it is shown how that isocyanate is formed. Nitrogen atom in nitrine is electron deficient and serve as a center for 1,2 rearrangement reaction. Addition of water to isocyanate produce unstable carbamic acid, which on decomposition produce amine. Example of this type of rearrangement is Lawson rearrangement. Rearrangement of activated hydroxamate generated from corresponding hydroxamic acid. Activation is done through O-acylation or O-arylation or O-sulfonation. In this case, the substrate molecule is taken, and when base is added, that base abstracts the proton which is associated with that nitrogen. Then R group migrated from carbonyl group to nitrogen. After that, isocyanate is formed, and when water is added to isocyanate, and after that decomposition of that intermediate product, removal of carbon dioxide takes place, and final product is amine. Hence, in Lawson rearrangement, hydroxamate is converted to amine. Now third type, rearrangement to electron deficient oxygen. In this case, oxonium ion is an intermediate. In this reaction, cumene is the starting compound. Cumene on oxidation produce cumene hydroperoxide, and when this cumene hydroperoxide react with acid, there is conversion of bad leaving OH group to good leaving OH2 group, OH2 positive group. This OH2 positive is good leaving group, that's why it leave the molecule, and after leaving that OH2 positive, that oxygen get positive charge, migration of phenyl ring taking place, and finally when addition of water is there are formation of two products, one is phenol and another is acetone. In this type of rearrangement reaction, divalent oxygen atom converted to tricoordinate oxonium ion. Tricoordinate oxonium ion is converted to electron deficient unicoordinate oxonium ion. 1,2-alkyl or aryl shift convert less stable oxonium ion to more stable carbocation. Now sigmatropic rearrangement. In sigmatropic rearrangement, sigma bonded atom or group present between one or more pi electron system shift to new location with rearrangement of pi bonds. The total number of pi bonds remain unchanged, as well as total number of sigma bonds also remain unchanged. Rearrangements are described by two numbers in bracket which refer to the relative distance in atoms each end of the sigma bond has moved. In this case, that numbering is shown, that oxygen is number 1, then number 2 is benzene carbon, then number 3 is another benzene carbon. In other side, the atom next to oxygen is denoted as 1, next carbon is denoted as 2, and another carbon is denoted as 3. There is interaction between 3-3, that's why it is shown 3-3 sigmatropic rearrangement. Claisen rearrangement is the example of sigmatropic rearrangement, and in this case 3-3 sigmatropic rearrangement occur. Allyl vinyl ether is converted to gamma delta unsaturated carbonyl compound, and it is shown in this structure. Allyl vinyl ether on treatment with heat produce gamma delta unsaturated carbonyl compound, and in last structure the mechanism is shown. Now let's see Beckmann rearrangement. In Beckmann rearrangement, rearrangement of ketoxime in acidic medium is take place, and the product is N-substituted amide. In this case, ketone is the starting compound. It reacts with NH2OH, that is hydroxyl amine, and corresponding oxime is formed. This oxime on treatment with acid, the OH group is get protonated to good leaving OH2 positive. This OH2 positive leave the molecule. R group which is present at the adjacent carbon atom move towards this nitrogen and rearrangement take place. And finally, nitronium ion is generated. Addition of water across that nitronium ion produce another intermediate, and there is N-substituted amide as the final product. In this case, ketoxime is first of all generated by using NH2OH, that is hydroxylamine. Ketone plus hydroxylamine that produce ketoxime, and after that protonation of OH group of that ketoxime take place. OH is converted to OH2 positive. As it is good leaving group, it leave the molecule. At the same time, migration of R group taking place. There is formation of nitronium ion as an intermediate, and when water is added, there is formation of N-substituted amide as a product. These are some features of Beckmann rearrangement. This rearrangement is catalyzed by acid. Sometimes other catalysts like thionyl chloride, that is SOCl2, tosyl chloride, phosphorus pentachloride can be used for this reaction. Acid or acidic reagent convert OH group, which is bad leaving group, into good leaving group. Alkyl or aryl group, sometime hydride, is also migrated, and this group anti with respect to leaving group, they are generally migrated. Addition of water to intermediate carbocation produce corresponding amide. This is the example of Beckmann rearrangement. It is unsymmetrical ketone. Two different groups are attached to that carbonyl group. From one side there is methyl group, and from another side there is propyl group. In this case, when this compound is treated with hydroxylamine, two different oximes are formed. In one structure, OH and methyl group are on the same side. In another structure, OH and methyl are on opposite side. And when this intermediate, that is oxime, is treated with acidic reagent, there is formation of two products. One is major product and another is minor product. In unsymmetrical ketone, two different geometrical isomers of oxime are formed. The group which is trans with respect to OH group migrate to give the major product. This is another example of Beckmann rearrangement. In this case, oxime is shown. OH group is get protonated with H plus from H2SO4. OH is converted to OH2 positive. Then it leave the molecule, and after that bond migration is taking place. 6-member ring is converted to 7-member ring. Addition of water produce E-caprolactam as a final product. Hence, we can produce E-caprolactam from cyclohexanone. Cyclohexanone is converted to corresponding oxime, and after that it undergo Beckmann rearrangement and there is production of E-caprolactam. This E-caprolactam on treatment with base produce nylon, and it is shown in below reaction. E-caprolactam, when base is added, that cyclic structure is ruptured and open chain structure is obtained, that is nylon. This is another example of Beckmann rearrangement. In this case, benzophenone is starting material. It is ketone. It reacts with hydroxylamine. Oxime is formed. As it is symmetrical ketone, orientation of OH group can be any side. After that, protonation of that OH group take place. OH is converted to OH2 positive, and after that migration of one phenyl ring to that nitrogen take place. Another intermediate is produced, and after that addition of water we get benzanilide as an product. This is the example of Beckmann rearrangement. This is next example. In this case, acetophenone is the starting compound. Acetophenone on reaction with hydroxylamine produce corresponding oxime. Oxime on reaction with acid produce good leaving OH2 positive group. It leave the molecule. Intermediate carbocation is obtained. Addition of water produce N-methyl benzamide as a product. Student assignment. We have discussed various aspects of rearrangement reaction. On the basis of the discussion, you should answer the following question. What is the rearrangement reaction? Discuss 1-2 rearrangement reaction with example. In this question, you have to give the definition of rearrangement as well as you have to give discussion regarding 1-2 rearrangement reaction. Explain reactive intermediate involved in different rearrangement. We have seen different intermediate like carbocation. We have seen nitrine intermediate. We have seen oxonium intermediate. All these intermediate you have to explain. Then explain mechanism of Beckmann rearrangement. Now summary of this session. We have start with rearrangement reaction. Definition of rearrangement reaction. Rearrangement reaction is the reaction in which carbon skeleton undergo changes or the functional group undergo changes. Sometimes carbon skeleton as well as functional group of the molecule undergo changes. In rearrangement reaction, there is migration of one group from one place to another place taking place. Types of rearrangement reaction. We have seen 1-2 rearrangement reaction. We have seen pericyclic rearrangement reaction. We have seen sigmatropic rearrangement reaction. Reactive intermediate involved in rearrangement. In this, we have discussed carbocation intermediate. We have discussed the stability of carbocation. We know that stability of carbocation is in the order that is tertiary greater than secondary greater than primary. That's why primary carbocation is trying to convert itself into secondary or tertiary. Then we have seen the mechanism of Beckmann rearrangement.